All right, so this is Topic 3, SAS 1 Overview. This is what we did in class today on September the 14th. So I'm just going to make a video for anyone who wants to go back and watch it, or anybody who is at home so they can still learn with us. All right, so first thing, it says a parent function is the simplest form of any particular function type. If you know the key characteristics of only a handful of parent functions, you can transform them to generate infinitely many models. A group of a function is said to be transformed when every point on the graph is changed by the same amount or in the same way. So, on number 1, it asks you, what does it mean to transform the graph of a function? Well, it means when every point on the graph is changed by the same amount or in the same way. Also, just a little side thing, transform simply just means to be changed. Okay? I'll give you a few seconds to write that definition on number 1. All right, so this animation that you see at the bottom will be used many times during this topic. So what we're going to do, we're going to move these blue arrows to make a new line. So number 2 says, state the slope and the y-intercept b needed to transform the graph of y equals x to fit the data represented in the scatter plot shown. Okay, so what I want you to do right now is to mess around with this to get it to be equal on the red dots. Oh, I'm almost there. All right, that looks pretty similar, okay? Looks like it's laying on the red dots, okay? And if you notice on your paper, it tells you in the bottom right corner of that graph, y equals 0.25x plus 2. And right here on our screen, it tells us y equals 0.25x plus 2. So m is my slope, and my slope is 0.25. And b is my y-intercept where it crosses, and that is 2. Okay? So you can stay on this screen, and I am going to flip to your workbook page. So on the next page, you have 4 questions, and this is hopefully just a review for what you have learned in the previous years. Okay? So, what we are going to look at first, it wants us to graph each line described. So first, we have 2 points. Okay? So what I want you to do right now is to plot these points on the graph first. Okay, so this is a linear function because it's a straight line. Okay, and I want to go ahead and talk about what the equation is. Okay, so first, our slope. We can look at our slope and see what it does, right? So we go down 1 over 1, 2. Down 1 over 1, 2. Is this positive, negative? Negative. And where does it cross? Plus 4. Okay? Another way to do this is y2 minus y1 over x2 minus x1, okay? We'll use this as the first set, and we'll use this as the second set. So we have 3 minus 5 over 2 minus negative 2. Well, 3 minus 5 is negative 2. And these two negatives become a positive, so this is a 4. We can simplify and get negative 1/2. These match. That's our slope, okay? And you can look at your graph and tell that it crosses at positive 4. Now, on B, it says you have a slope of negative 3 and a y-intercept of 2. So remember, we always start our y-intercept. So I'm going to go ahead and put this on positive 2. Okay? We have a slope of negative 3, so it's going to be going down. So we're going to count 1, 2, 3 over 1. 1, 2, 3 over 1. Now, if I want to go up, I have to say 1, 2, 3 into the left 1. So here's my line. So my equation is y equals negative 3x plus 2. Okay? Remember, you can pause this video anytime you need if I'm going too fast. Alright. I want to go down just a little bit. Okay? Now, this says it has an x-intercept of 3. So what that means, instead of it crossing on the y, it's crossing on the x. So, 1, 2, 3. Okay? And a y-intercept of negative 2. Now, we know our y-intercept is negative 2. Our slope is positive because it's going up. So we're going 1, 2, 1, 2, 3. So 2 over 3x is our slope. Alright, D. It passes through the point of negative 3, positive 1. So I'm counting 1, 2, 3, up 1. Okay? And it says it never intersects the x-axis. So if I drew a positive slope, it crosses the x-axis. So that can't be right. If I drew a negative slope, it still crosses the x-axis. So that would not be right. If I drew a vertical line, nope. I have to draw a horizontal line with no slope. So my equation here would be y equals 1 because it crosses right here at positive 1. Okay? Alright, on the next page, you're just writing the equation. For A, B, and C. Alright, I am going to flip back over to number 5. Alright, and it says on our screen, in the previous activity, you altered the slope and y-intercept of the function y equals x to find a set of linear data. You can transform y equals x in this way to fit any set of linear data. This is why we call y equals x the parent function for all linear functions. I'm highlighting key stuff, okay? As you know, y equals x squared is the quadratic parent function. and y equals b to the x power, where b can be any positive constant that is not equal to 1, describes the family of exponential parent functions. So, on number 5, it asks us, what rule describes the family of exponential functions? Well, I just highlighted it. Y equals b to the x, where b can be a positive constant that is not equal to 1. So anything greater than 1. Number 7, I just underlined it too, or highlighted it. It says, what is the quadratic parent function? Y equals x squared. Okay? Now, on number 7, it says, compare the rate of change, which is just a fancy word for slope, of linear, quadratic, and exponential functions. How would transforming each function impact its rate of change? So I'm going to hit play. And first, we have linear. Okay? Linear has a constant rate, addition, and slope. All of these terms, rate, addition, and slope, are all very similar terms. So what that means is each time it is going up by the same number. Okay? And we've learned this in topic 1 and topic 2. All right, number 2 shows us exponential. Remember, exponential kind of looks like a Nike sign. And it has a constant multiplication. All right, last is quadratic. And quadratic has its own little thing. This right here is my first difference. This right here is my second difference. Remember, quadratic is when the second difference is the same. And it forms a U, which is called a parabola. All right, so I want you to mark out number 8. We're just going to talk about this page, and it actually goes with 9B, but we're going to wait on 9B for right now. We're going to hit that in class on Thursday. So this right here is called an absolute value function. Okay, this point in the zero or in the center is 0, 0. But this point, after it's transformed, is positive 4, positive 2. So what that means is that it is moved to the right 4 times, but it's also moved up 2. Okay? Now, I want to talk about 9A and 10. Okay. Number 9 says, a linear function passing through the origin, which is 0, 0, and the point -8, -2. And the directions tell us to graph each function described and write the equation. So first, I'm going to use y2 minus y1 over x2 minus x1. Alright, right here we have to do two things. Two negatives make a positive. And then we have to simplify to 1 over 4. So 1 over 4 is my slope. So now I am going to erase this, and I'm going to graph these points. So I have one at 0, 0. And then I have one at -8, and I'm going to make my tick marks go by 2. Alright. Now, our equation, we just said that our slope was 1 over 4x, and my y-intercept is just 0. So you can write 0, or you can just say 1 over 4x. Okay? Okay. On A, graph each function and identify the family type. This is what type of function? Exponential. Okay. So when you graph it, you get something like this. And I told them in class today, exponential functions never touch 0. If you look on your graph, when your x's are negatives, you'll notice that the exponent, or not the exponent, the scientific notation, it just gets bigger and bigger and bigger. So this right, know that exponential functions never touch 0. They just get real close. Okay? Alright, the last one we are going to do is 10B. And we're gonna do first, outside, inside, last. Or you can use this box. So we have 1, 2, 3, 4 terms essentially, hence why we have 4 boxes. So up top, I'm going to have x plus 2 and x minus 2. So everything on the outside we multiply. So x times x is x squared. X times 2 is 2x. Negative 2 times x is negative 2x. And negative 2 times a positive 2 is negative 4. Everything on the inside we combine. I don't have any other x squared terms, so I'm bringing it down. These two x's cancel because one's negative and one is positive, and I'm bringing down that -4, okay? So then you can graph this or this, and you'll get the exact same thing. And that's what it looks like. And this is a quadratic graph. Alright, that is all for today's lesson. So I will get this uploaded and I will see you in class on Thursday.